Happy Monday, guys. Hope you're enjoying the dreary weather and the rain, but hey, at least there might be a snow day on Wednesday, so who knows. All right, so what I'm going to do here is, because of this potential snow day, and I really think we need this day, but then again, hey, if snow happens, it is what it is, it's cool. I just want to go through notes 9 and just kind of finish up sort of the things I didn't get through last time and maybe clarify the last problem we did, because I think some of you guys saw that problem where it's like the whole like sine and cosine thing, but it goes up and down, but like just the logic was a little too quick, so I'm going to try to take my time with that here. So again, put this on times 2 speed if you feel like it. I'll try to put some chapters and timestamps so that you can skip to the questions. I'm going to do the 3 types. So scroll on down past notes 9. First type here is something like question 5, where you're using a calculator to answer the question. Question 7 through 9, we'll do one of these questions just to get an idea of what this looks like on Desmos. And then the last one here, we'll try to pick up where we left off at. The key is already posted, so you guys have it, but I'm just going to walk you through the process in case what I wrote in the key doesn't seem to click together. Okay, so we'll start with number 5. So the question, or the prompt asks us to use a calculator to solve each question on the interval from 0 to 2 pi. So we see that sine of theta equal 0.8. So we know that ratio is about 4/5, but we don't know what that angle is going to be. So in this case, this is the weird part where we kind of mentioned you shouldn't do this, but for this case, we're going to have to. We're going to have to convert this into an inverse sine function. So inverse sine of 0.8 is equal to theta. Now, you would have to plug this into a calculator, but you have to remember, when we do inverse sine into a calculator, or any inverse trig into a calculator, the problem is that it only gives us one angle. Recall, if I draw this out, this will only give us where sine of theta is equal to 0.8. It's, remember, this is where the sine of that angle is positive. For inverse sine, that's going to be stuck in the first quadrant. And so we're going to say that's going to be theta, and then we can find exactly what the angle is using a calculator. Here's the problem, though. We're not answering what the inverse sine of 0.8 is. We're answering this question up here. What angles have a sine ratio of 0.8? Because this is our starting point, we have to remember sine is positive in another quadrant. This is actually going to be in quadrant 2. So we need to actually find 2 angles. We've got to find that angle, and then we need to find this whole angle right here. Okay. Now, to be fair, I think one thing I didn't harp on enough back when we first did trig is this idea of reference angles. So let me do a quick example and then we'll kind of apply it here. So reference angles are basically connections that you create from the first quadrant to every other quadrant. For example, let's do pi over 6. It's a really basic example. Let's just change it to 30 degrees because I think those will be easy for you guys. If that's theta, and we say theta is 30 degrees, then how do you find every other angle? Well, you would say the angle that's reflected over the y-axis, or on this side, you would call this 150 degrees. Why is that the case? How did I figure it out really quickly? Because it's the same triangle reflected over, and it's got a reference angle of 30 degrees. This angle right here is 30 degrees. We can do the same thing for every other quadrant. Every other quadrant, we know that the reference angle, the angle to the x-axis, is always going to be 30 degrees. I probably shouldn't have mentioned this when we first started in trig, because I think some of you guys were like, Mr. Park, how are these different triangles coordinated? It's because all their reference angles are 30 degrees. How do you get 150? Well, pretty straightforward. You take pi minus that angle, or 180 degrees minus that angle, minus theta. Theta in this case was 30, right? So 180 minus 30 is equal to 150. To get the next one, you do 180 degrees plus theta. For the last one here, you have to do 360 minus theta. And that's how you get the sort of actual angle in the unit circle itself. So this is where all of these sort of formulas and not ratios, but just sort of how you find the actual angle itself is super useful. So in our case, just so that we're crystal clear, in our case, to find this red theta that I kind of highlighted here, what we're really going to need to do is we need to find this theta. So once we find the green theta, what we'd have to do, we have to do pi minus that green theta to get to this angle itself. I'm going to not call it theta because it's a little misleading. Let's just do it like that. So first we need to find theta, and lucky for you, your calculator does that for you. Roughly speaking, I'm not going to put this in my calculator right now because I've already done the answer here, but the answer should be roughly something like this. If theta is equal to like 0.0801, and now you might be saying, Mr. Burke, how do I know if that's in the first quadrant or the second quadrant or the third one? It's called basic logic. You know that the first quadrant is from 0, let's say 0 to pi over 2. Pi is 3.14, roughly speaking, divided by 2. That's about 1.57. Is 0.08 in that range? Therefore, yes, it's in quadrant 1. So because we know it's in quadrant 1, to find the other angle, so to find the second angle, we know this is the first angle that exists. Second angle, so we can say second theta, is going to be equal to the 180, or sorry, since we're in radians, we got to do pi minus that, and then that'll give you your second answer. So again, there are 2 answers total. You need to make sure you look for the second answer. The calculator will give you the first one using logic and using this idea of reflections over the x or the y axis, and also the formulas of pi plus 180 or pi minus 180, depending on which quadrant you're in. That should give you the second angle. All right, number 7, great example here. How do we solve this without using algebra and instead using a graphing calculator? So what you're going to do is in Desmos, I'm not going to actually show you this, I'm going to explain how this works, because hopefully when you see it, it's like, oh, it makes sense. In Desmos, the first row where you're actually entering data, you want to type in y is equal to the left-hand side. Then in the second row, you type in y is equal to the right-hand side. You type both of these equations into Desmos, you get a graph. This graph right here looks kind of something like this. It's going to look like a sine wave that goes up. And I say sine because it's usually easy to remember. And then y equals 0 is going to give you something that kind of looks like this. Okay, I'm going to be off by a little bit because I'm just sketching it. But what happens is the 2 curves here intersect. Or I should say, the sine curve, or the cosine curve, intersects with the linear function here. Where their intersection is determines, oh, cool, that is exactly where the answer is. Where they intersect, exactly the answer. Now, just to clarify, because I think depending on the scenario, you're going to be a little bit careful here, because in some cases you will have infinite answers. So something that might be useful, and in this case I don't really clarify, but what we're trying to do is we make sure that we're, again, going from 0 to 2 pi. Now, here's the weird part. I didn't clarify here. So I think what I'm trying to get you guys to do is write every answer down, because luckily for you, for all 3 of these, there's only a finite number of answers. So number 9 is going to be a little crazy. You got about like 7 answers, but it's not like infinite as you would see in most like sine or cosine equations. So all these, there is only one answer, or a finite number of answers. But just be mindful that if we're trying to find the intersection from 0 to 2 pi, you have to limit your answers accordingly. So just keep that in mind. And I think the first one here, you guys have the answer key, should be right there. So just showing you how it's done, okay? Moving on to the last one here. I'm going to skip to where we left off at. So if you need a quick refresher, just go back to your notes or take a look at the key to kind of compare what you had with what I had. So I think we were last leaving off, if I recall correctly, we basically found out that for question A, we found out that the low tide is where D is equal to 7, and we said the high tide is where D is equal to 63. Just double check. Yeah, 63. And this is in feet, so let's keep our units straight. So in essence, what's happening is there's a low tide and a high tide. So a low tide happens here and a high tide happens here. And it just repeats over and over because, like we know before, weather is cyclical. Things that happen in the world are fairly cyclical. So we're saying that the low tide is at D is equal to 7. The high tide is D is equal to 63. So what we're saying is, what time does low tide happen at a depth of 7 feet? What time does it happen when the high tide is 63? So we need to figure out what that time interval is. Lucky for you, you have that formula because it's given right here. So we can plug in D is 7 is equal to 35 minus 28 cosine of all that garbage. And then same thing here, 63 is equal to all that crap. Now, we eventually figure out if you solve for T, so using what we did last time, we only did a high tide, I think. And so the high tide, we got that the time is roughly equal to 6.2 hours. The low tide, if you do the exact same process, you do all the work, we pretend we've done everything all dandy, you get 0 hours. So now we need to convert this into actual time. If we're saying that at time equals 0, the low tide is 7, then therefore it happens at midnight. Because we notice here that consider a day in which t equals 0 represents midnight. One of our answers was that, therefore the answer is midnight. Now that means t equals 1 is 1 o'clock, t equals 2 is 2 o'clock, and so on and so forth. 6.2 hours, convert that 0.2. We know 0.2 of an hour is the same thing as saying 1/5 of 60 minutes, which is exactly 12 minutes. And so we can therefore say at 6:12 a.m., that is where the high tide is going to be. Now, my answer key has a much more robust answer. I'm just getting you guys to think about the process. The full answer at the end, you will need to compare it with that. So 12 a.m. is the low tide, 6:12 a.m. is the high tide. Please make sure you write that down and not just do what I just did here. Do as I say, not as I do. So now that we have that, you might think, oh, we're done, right? We're cool. Something you've probably forgotten is, remember that idea of the cycle? Low tide, high tide, low tide, high tide. So here it's at 12 a.m., so right on the dot. And this one is going to be at 6:12 a.m. Wait, hold on. If we logic this, isn't it possible that if I have a period here and then a period here, that these numbers could still be within the same day? I.e., there are 2 low tides and 2 high tides. There could be 3 low tides and 3 high tides. So the next goal is to figure out is what the heck is this period? Is it 2 pi? Is it so in this case? So think about the time frame here. Is it going to be 6 hours? Is it going to be 12 hours? Is it going to matter? So what we need to find out is to find the period. So goal is going to be to find the period. So I'm going to do it in black here, just so I don't get you guys confused. Goal is to find the period. So in order to find the period, well, we first need to figure out where exactly the period comes from. And if we recall things that we did from the aspects of trig functions and graphing it, this part right here, the b value, determines the period. So recall, so we're going to say the period is what we're trying to find is equal to 2 pi, the original period of a sine or cosine function, divided by that b value. So remember that b value was, I think, pi over 6.2. And when you figure this out, you end up realizing that the period is, funny enough, 6.2. So once you have that down, and I think I actually messed up there because it's actually going to be pi's cancel out. Oh, it's 2 times 6.2, so it's 12.4 hours. So every 12.4 hours, so almost 12 and a half hours, you get to a part where you repeat the cycle again. So that means from what I drew before, low tide, high tide, low tide, high tide. The distance from these 2 high tides is 12.4 hours. So if we do that math real quick, 12.4 hours, roughly speaking, is about, if we do it in time frame, it's about like 12 hours and 24 minutes. Because 4/10, that's 2/5 of an hour. 2/5 of 60 is indeed 24 minutes. So when we add it to the low tide, we get 12 hours, 24 minutes added to the low tide. That becomes 12:24 p.m. for the second low tide. And then if we add 12.24 to 6:12 a.m., you get 18 and 36. So 18, that converts into normal time as 6 p.m. 36. I did that the military time when you could have easily done that just by saying, oh, what's 12 hours after 6 a.m.? Oh, that's 12 p.m. Pretty easy. So you have the second high tide and the second low tide given here. So keep that in mind, the period is important, right? So again, we're taking a lot of concepts we did back in the past, just applying it here. Now, last part is going to be for letter B. This one I'm going to keep pretty straightforward because, again, you're trying to find where the time gives you a depth of 3.5. So one way you can go about it is saying 3.5 is equal to all that junk again, solve for t, go from there. Or a much faster way is to think about the logic of it. Let me remind you again. The low tide here is 7 feet. The high tide here is going to be 63 feet, roughly speaking, right? It's asking you, when does the tide ever get to 3.5 feet? Hopefully looking at this, you can be like, oh, logically, yeah, that makes sense. So I'm going to leave that for you guys to figure out. Hopefully this helps a little bit, just to try and provide a short sort of snippet on the things that we can get over in the event that we do have a snow day on Wednesday, which I kind of hope we do, but also we don't. I am conflicted. Anyways, hope that helps, guys.